Today, we want to continue solving oblique triangles with the law of cosines. If you recall, last time we introduced the law of cosines as kind of a generalized Pythagorean theorem. It's the Pythagorean theorem, but if we don't have a hypotenuse and a 90-degree angle, then we have this extra term. The reason it's the generalized Pythagorean theorem, if gamma is a 90-degree angle, then the cosine of 90 is equal to 0, and this term drops out, and C we can call the hypotenuse, because C will be opposite a right angle. So this is what we do if we don't have a right triangle. This is one of the things that we do if we don't have a right triangle. We also talked about when we use the law of cosines. We can use the law of cosines to solve for an angle, or we can use the law of cosines to solve for a side. And the different forms tell us what information we need to use the law of cosines. So, for example, if I want to solve for angle gamma using this part of the law of cosines, I need to know A, B, and C. I need to know all three sides. So we came up with a code for this. We called this SSS case, where we have three sides. So we can use the law of cosines to solve for an angle when we have all three sides. Once we have one angle, we can actually just use it to solve for the other angles. But once we have two angles, we should just subtract to find the third angle. And once we learn about the law of sines, we're probably going to want to do that for the second angle. But if we have three sides and no other angles, we can use the law of cosines to solve for our first angle. We can also use the law of cosines to solve for a side. If I want to solve for side C, notice that I need A and B and the angle gamma. I need A and B, they show up twice, but the angle gamma, I need the angle opposite the side that I'm looking for. Another way to say this is I need the angle that's included in the sides A and B. So we use the law of cosines to solve for a side when we have two sides and the included angle. So if I have side A and B and angle gamma, that's a law of cosines. That's the SAS case. We write the A in between the two S's because it's two sides and the included angle, the angle between them. Then we just got to notice that the C is opposite gamma, B is opposite beta, A is opposite alpha as normal. And then we got to learn our patterns to make sure we're subtracting the correct one. Notice that the opposites, the angle, the alpha, and the A, those are the ones that only show up once. The other two, B and C, show up twice. Beta is opposite B. Those show up once. A and C shows up twice. Beta is opposite B. Beta and B show up once. A and C show up twice. Let's look at an example. Let's suppose that side A is equal to 15, side B is equal to 21, and side C is equal to, has to be less than the sum of these two. So 15 and 21 is 36. C has to be less than 36. So C can be, how about 30? So once I said 15 and 21, C has to be less than 36 because I can't have one side bigger than the sum of the other two. But then I couldn't make C too small because 21 would have to be bigger than the sum of the 15 and whatever side I picked for C. So suppose that we're trying to solve a triangle and we're given all three sides. So we identify this, we have all three sides. This is the SSS case. And that means we should use the law of cosines. Right now we have minimal information. We only have three things. So that determines what we have to do in the first step. Once we get past the first step and have an abundance of information, we have choices to make. So we're going to use the law of cosines to solve for one of the angles. And it doesn't matter which angle we solve for, but the first one I have listed here is gamma. So I'm going to solve for gamma. I'm going to say gamma is the cosine inverse of a squared plus b squared minus c squared. So a squared plus b squared minus c squared all over 2 times a times b Here's why we would want to write the angle and the side formulas all in one go like this, not just plug things into our original law of cosines and then manipulate things. Pre-manipulate things so that when we go to the calculator, we can plug this in all at once. So first, I'm going to make sure that I'm in degree mode, which I am. Then I'm going to do second cosine for cosine inverse. Now, I need to put some extra parentheses in here. So let's highlight some extra parentheses that we need. I need parentheses around the numerator because I want to make sure I take this sum and divide it by this product. So I'll need parentheses around the denominator as well. So I'm going to do a cosine inverse of the numerator, which is parentheses 15 squared plus 21 squared minus 30 squared. Close the numerator, divide, open the denominator, 2 times 15 times 21. Close the denominator, close the cosine inverse, and cross fingers and hit enter. And it looks like angle gamma is 111.8 degrees. Then we make sure that this makes sense. 111.8 is going to be the biggest angle because we can only have one angle in a triangle that's more than 90 degrees. And it is opposite the biggest side. So right now things seem to make sense. I can solve for one of the other angles using the law of cosines. We have an abundance of information, but we don't know the law of sines yet. So I'm just going to use the law of cosines again. So beta is going to be the cosine inverse of a squared and c squared minus b squared. So 15 squared plus 30 squared minus 21 squared divided by 2 times 15 times 30. And I'm still going to need parentheses around the numerator and the denominator. Let's got to go switch the role of the 30 and the 21. So I'm going to go 15 plus 30 squared minus 21 squared. And I just realized I could have just changed the signs. Cross fingers, hit enter. And it looks like angle beta is 40.5 degrees. Once we have two angles, we should always just subtract to find the third angle. That's the same rule that we had before. The sum of the angles in a triangle is still 180 degrees. So alpha is just 180 minus the 111.8 minus the 40.5. Once we have two angles, subtract to find the third. So 180 minus 111.8 and also minus 40.5. 27.7. The internal check is that the biggest angle is opposite the biggest side, the middle angle is opposite the middle side, and the smallest angle is opposite the smallest side. So at least this passes inspection. Note that we could use the law of cosines to solve for alpha if we wanted to be super extra about things. So we could just go up to and trade the roll of 15 into 21 this time. So 21 plus 30 minus 15 squared, and then divide by a 21 times 30. And we still get the 27.7. We could just be like all in. Law of cosines is so awesome. I'm not going to subtract. I'm just going to use it again and solve that way. But once we have two angles, as soon as you have two angles, subtract to find the third. Or use the law of cosines again. I mean, sometimes you just want to be extra. Any questions? It's really important that when you have a calculator that can do the whole calculation at one time, that you only hit enter one time for your calculating in your calculation. Your calculator has this ability, so we should utilize that ability. It's much more difficult if we have to do things in pieces, because then we have to be careful about where we hit enter. Any questions? Let's do an example where we're given the side angle side. Let's suppose that A is going to be 23. Side B is going to be, let's make B the, B is, I always make B the middle child. So let's make B the youngest again, youngest. So B is going to be 17. Now I want to use the law of cosine. So I either have to give you side C, which we just did, so I don't want to do that again, or angle gamma. So I have to give you kind of an A, a B, and a C. Kind of have to give you like a full set of information. So I give you two sides and the included angle. The included angle is the one that's not opposite either of these sides, so I have to give you gamma. And let's say that gamma is equal to 57 degrees. So I have two sides and the included angle. So this is the SAS case. Because I have two sides and the included angle, because gamma is not opposite B or A. So that means law of cosines. The side that we solve for is opposite the angle that we have. So if you're using the law of cosines and it's your first, from the SAS case, solve for the side opposite the given angle first. We didn't have to make this decision in the SSS case because we had all three sides. We needed to find all three angles. We just had to pick one to start with. But in the law of cosines in the SAS case, the first thing that the law of cosines is going to be used, since we have gamma, we have to use gamma to find C. So in general, you need to solve for the side opposite the given angle first. So we're going to lead with C equals the square root of A squared plus B squared minus 2ab times the cosine of gamma. Since our calculator can handle this calculation in one entry, it should handle this calculation in one entry. So I'll do a square root of 23 squared plus 17 squared minus 2 times 23 times 17 times the cosine of 57. And I'm going to close my cosine and close my square root. So 2317 minus 2, 2317 cosine 57. So it looks like side C is going to be 19.8. This is not degrees, this is a side, so 19.8 units. At this point, we have an abundance of information. We have all three sides, so we could use the law of cosines to solve for an angle. We could also, what we're more likely going to do is use the easier law, use the law of sines, since we have an opposing pair. But now we have an abundance of information. Now we have choices to make. In both cases, we're going to have to use the 19.8. So we could use the law of cosines again, because we have all three sides. Now that we have all three sides, we can use the law of cosines again. The SSS version. So now that we have all three sides, we can use the law of cosines to find an angle. So I could say beta is going to be the cosine inverse of, so b is going to appear once, so I'm going to have a squared plus c squared minus b squared over 2ac. Now, I'm still going to need parentheses around the numerator and parentheses around the denominator, because my calculator has to write everything in single line syntax. So my calculator doesn't know where I want the numerator and the denominator of my division symbol to be. So I'm going to use an extra set of parentheses to make sure it's there. I also don't want to round off this 19.8, because what if that 0.80132002 could make a difference? Fortunately for our heroes, there's a button above the change the sign button is ANS. And so if we bring that up, that button is now a 19.80132002 button for your calculator until we hit enter again and it comes up with a different number. So I'm going to do cosine inverse of the numerator, which is 23 squared plus the 19.8. So I need second answer. And that ANS is going to be a 19.8 because that's the last thing the calculator entered. So 19.8 squared minus 17 squared, close the numerator, divided by, open the denominator, 2 times 23 times my 19.8. Close the denominator, close the cosine inverse, double check to see I have everything in place. 23 squared plus 19.8 squared minus 17 squared, all in parentheses. 223 and 19.8 in parentheses, cosine inverse. So it looks like angle beta is 46.1 degrees. At this point, we could use the law of cosines again to solve for angle alpha, but notice that we no longer have a 19.8 button. Now the answer button is going to be a 46.056355358 button, and that's not what we want if I want to use for alpha. But also, fortunately for our heroes, we have two of the angles. As soon as we have two angles, subtract to find the third. So we'll just do 180 minus the 57 minus the 46.1. Oh, actually, I can use the 46.1 button that I have. And I get 76.9. Let's make sure this passes the internal logic check. Is the biggest angle opposite the biggest side? Well, it looks like the big angle is big side is 23, and the big angle is alpha, 76.9. The smallest angle is 46.1, which is beta, which is opposite the smallest side. And the middle angle of 57 is opposite the middle side, 19.8. So at least this passes our basic inspection. We did not get error when we hit enter at any point. And the angles and the sides are opposite the biggest, middle, and small. We have quite a lot of power when we use the law of cosines, which is why I start with the law of cosines. Calling this the law of cosines and not just how to solve for oblique triangles kind of implies that there's going to be a law of sines. Usually when we have an abundance of information, we will switch to the law of sines because the law of sines is a simple proportion. So usually, we will switch to the law of sines once we have an opposite set of information, once we have an abundance of information. I refer to this as an abundance of information because we have more information than we need. This is not a common term, so I'll put it in quotes. This is a Leachism. And by abundance of information, I mean a side and the angle opposite that side. Once we have an opposing side and an angle, a gamma and a C, a beta and a B, an alpha and an A. Once we have an opposing set of information, usually we switch to the law of sines because the law of sines is just a proportion, and so it's easier to implement. But the law of sines has its own little quirks that we have to be aware of. At this point, you must be wondering, what is this law of sines? You haven't mentioned any of it except for in this kind of abstract existence. So let's write down the law of sines. The law of sines states the following. Same triangle, alpha opposite A, beta opposite B, gamma opposite C. The law of sines says that the sine of an angle, the ratio of the sine of an angle to the side opposite that angle in any triangle is constant. So the law of sines if we just want to spell it, we'll say sine alpha over A equals sine beta over B equals sine gamma over C. What we're saying is that the ratio of the sine of an angle to the side opposite that angle is constant in any triangle. The ratio of the sine of an angle to the side opposite that angle is constant in any triangle. The ratio of the sine of an angle to the side opposite that angle is constant in any triangle. As a formula, sine alpha over A equals sine beta over B equals sine gamma over C. So we can see what we need here. We use the law of sines if we have an opposing set of information, an A and an alpha, a B and a beta, or a C and a gamma. That's when we use the law of sines. Let's make sure that this tracks. Let's take the triangle that we just solved. How convenient for us. Let's take the sine of 76.9, sine of 76.9, and divide that by the side opposite, that is 23. So the ratio of the sine of the angle to the side opposite that angle is 0.0423467812. We're not going to get that much because I rounded off to 76.9. If we look at the sine of 46.1 to the side divided by the side opposite 46.1, which is 17, I also get 0.042, and my 3 became a 4, but rounding. And then if I take the sine of 57 and divide by the side opposite that is 19.8, 0.04235. So it works for, well, the nearest thousandth, which is pretty good. So that's the law of sines. It's the ratio of the sine of an angle to the side opposite that angle is constant in any triangle. We use the law of sines when we have an opposing set of information, a side and the angle opposite that side. I usually refer to this as opposing information. I don't know where I started calling it this, but an alpha and an A, beta and a B, gamma and a C. So if you're given an angle and the side opposite that angle, that's the time to use the law of sines. That's why I say we usually switch to the law of sines once we have an abundance of information, because once we have 4 pieces of information about a triangle, we're going to have an angle and a side opposite that angle. Also note that we can't use this in the law of cosines case. If I have all 3 sides, I can't draw one. I can't write. Well, it's true, I can't draw. If I have all 3 sides, A, B, and C, I can't write one proportion because I need opposing information. If I have 2 sides, A and C, and the included angle beta, I can't make one fraction equation. So I need to have a sine alpha over A equals sine beta over B. I can't have my three givens spread out over all three parts of the law of sines. So that's the other reason I cover law of cosines first, because it has specific requirements. And then once you have the law of cosines, you can just say use the law of sines when you can't use the law of cosines. Or use the law of sines when you can. If you can't, then it's the law of cosines. So somehow that makes sense in my mind. And it just, the only way I can make sense of solving oblique triangles is to lead with the law of cosines. I've never seen a book that leads with the law of cosines, and I don't know why. Maybe I just need to read more trig books. Who knows? All right. Just as a heads up, on Wednesday, I will not be able to have the meeting at the normal time. I will be on the road. And so the law of sines examples, I'm going to have to record, and I'm going to post those on the old YouTube. So I will be having an office hour. There will be an announcement on Canvas saying, announcing a time that I can have an office hour for some in-person questions. And I'll have the instructions on how to access that, because it'll be a different room than this one. I'm going to have open it up to all of my classes. And so I'm just going to be using my personal Zoom meeting. So all the instructions will be in the announcement. All right, that's going to do it for today. I will see you all. Well, I'll see you all in recorded form the rest of this week, but I'll be back. Okay, I'm going to cross my fingers and say I'll be back again on Monday. So I'm going to be traveling for a couple of days. So that's it for today. I'll see y'all next week. Everybody have a good week, and thanks for playing.